Welcome back. I know you missed me and my incredibly boring monotone voice. So we are going to shift gears here and we're done with sequences and series. We're now going to talk about Pascal's triangle and then the binomial theorem for the rest of our unit here. So Pascal's triangle, if you recall from last year, all right, it's going to be a triangle that is created by adding the two numbers above. So this is going to get wider and wider as we go. Notice how you're always going to have ones on the outside. So you're simply adding the numbers above, and notice how we increase by one term for each row. So again, I'm just adding these numbers above. So to get 6, I added this 1 and this 5. I added those to get 15. Okay. Notice how it's symmetrical. Okay, you see the pattern here. Now we can go on and on and on, but obviously it's going to get pretty tedious. Alright, we don't typically go beyond this row right here. So we're looking at 21, 35, 35, 21, 7, 1. Okay? So we give all of these rows actual numbers. We call this top one row 0. Right, we don't really care about this row 0. Okay, it really starts right here with this one. Okay, where we have the 1 and the 1. So this is row 1. This is row 2, row 3, row 4, and so on. Notice that the different rows, so if I look at row 2 here, there's 3 terms in row 2. Okay, so row 2 has 3 terms. Notice how row 3 here has 4 terms. Alright, row 4 has 5 terms. Okay, so if the row number corresponds to n, so if we say that the row number equals n, then your total number of terms is equal to n plus 1. Okay, so just be aware of that. Now, suppose you needed a number in, let's say, the 30th row. We're obviously not going to want to create this triangle for that number of rows. It would just be too tedious and time consuming. So luckily there is another way of getting these numbers where you don't have to continue on this pattern. And that way deals with combinations. When we talk about combinations, we're talking about n choose r or NCR on the calculator. So let's jot that down. Alright, so jot this down. So to get the numbers in Pascal's triangle, we can use this NCR button on our calculator, which if you're using an 84 plus, go to math and then PRB for probability and then arrow down to where you see NCR. So suppose we wanted to look at the row of 1, 4, 6, 4, 1, which we said is row 4. Okay, there's 5 terms in it, so it must be row 4. Alright, so this 1 is really found by doing 4 choose 0. Alright, if you were to do 4 choose 0 in your calculator, you're going to get 1. This 4, alright, notice how it's the second term in this row. This is 4 choose 1. Okay, if you did that in your calculator, you would get 4. And please make sure you are doing this at least once. Make sure you know how to use your calculator to find these. So the 6 is the third term. That's 4 choose 2. Okay. This 4 is the fourth term, so 4 choose 3 would be 4. And this 1 is 4 choose 4. Okay. So if we go back up top here to our N and our R, please make note once again that n is the row number. Okay, so here we're talking about the 4th row, and the r, well, notice how the r value with our first term was 0. The r value with our second term was 1. So you can see how the r value is 1 less than the term you want. Okay, So if you want the fourth term, the r value would be 3. Okay? So there's actually a formula for NCR. Okay? N choose R is equal to, by the way, sometimes we see it written as a vector with an N up top and an R in the bottom. In your formula packet, you will see it written as a vector N over R, like that. So using that notation. So here is the formula that is given to you. N factorial divided by R factorial times, excuse me, N minus R, that whole quantity factorial. So suppose we were to test this out on 4 choose 2. So maybe you're not allowed to use a calculator and you have to figure out what this is equal to. Well, we're talking about this as a vector if you were to write it like that. Okay, so this is 4 factorial over 2 factorial times 4 minus 2, that whole quantity factorial. Let me go up here, I have a little more room. So 4 factorial is 4 times 3 times 2 times 1. Alright, you just start with that number and you multiply down until you hit 1. Alright, hitting up every consecutive integer. 2 factorial is 2 times 1. And then when we do this piece right here, we end up with 2 factorial once again. So that's a 2 times 1. So 2 times the 2 here is a 4, which will cancel out with that 4. And we're left with just the 3 times the 2 times the 1, all divided by 1. So notice how we get 6, which is what we saw right here. Okay, so we just showed how to use that formula to prove that it's not just magic here. Alright, the calculator is actually using this algorithm to find that value. Okay, so sometimes NCR can be written as a vector. Here is the given formula in case that you do not have a calculator handy to find it. So you'll be expected to use that formula only if we don't have a calculator. Okay, last example. Suppose we're looking to find the 6th term in the 7th row of Pascal's triangle. So if it's the 7th row, we know that there are 8 total terms. Right? Now out of those 8, we want the 6th one. So if we want the 6th term, we said that the R value is always 1 less than the term we want. So using a combination here, this would be our row number, which is 7, and then choose, and then the R value, which is 5, right? Remember, we're using N choose R. N is the row number, and R is always 1 less than the term that we want. So if you are able to use a calculator, of course, just throw it into your calculator. If not, then if we're using our formula, it would be 7 factorial all over 5 factorial all over 7 minus 5, that quantity factorial. So we're looking at 7 factorial over 5 factorial times 2 factorial. So when we expand this out, a lot of this is going to end up canceling out. And then we have that. So the 5 through the 1 will cancel out this 5 through 1. We're just left with this 7 and this 6, and then this 2 and this 1. We know that this 2 will divide into that 6 3 times, and we're left with 21. Right? 7 times 3. So check that on your calculator. You can also go back to the first page of notes where if we actually did write out that 7th row, and you would see that the 6th term was in fact 21 in Pascal's triangle. Okay? Next video we're going to take a look at how this is actually useful.